GAC, how's it going today? It is Coach Jay, and we are hopping today. Hope you're doing well, and hope everything's all right. We are right now at 8:36 at night on a Tuesday. And we're going to get rolling here together. I'm going to waste very little time, and we're going to get right to it. Hey, if you could tonight, shoot me a message via email tonight or through the Remind or on my phone. If you do it through the YouTube link, I'll still have it up, but I won't check it as often. So just a heads up on that. And we will get it and go from there. So without further ado, let's get started. This is, again, Chapter 9, our last chapter test. Praise Jesus, right? Let's get after it. The one I want to just kind of look at, or kind of a couple that I want to look at, is this idea of completing the square with this parabola. Now, remember that anytime we're completing the square, there are very few on the review that are going to be like this. Or I'm sorry, very few on the test that would be like this, but there are a lot on the review that are on there that are this way. But we'll just look at a couple of them to make sure that we go through the logistics. So the first thing we want to do is make sure that we identify that it is in fact a parabola. And because the y is being squared, we're trying to get it into a form that produces y minus k squared that equals 4p times x minus h, okay? So that's the form we want to get in. So we want to make sure that all the y's are on one side, meaning the y squared minus 2y is on the left, and then everything pushes to the other side. So the 8x and the 15, we subtract 8x and we add 15 to the right side, and then we leave it as is. Now, once I move that to the other side and make sure that you do switch those signs, we then say, what can I do to make this a perfect square? Well, I can, as Nick says, half and square it. That's exactly right. We half it and square it. So when I half it, I get -1. I square it and I get +1. Okay. What I add to one side, I also add to the other. So we're left with -8x plus 16. And that equals y minus 1. And that is squared. Okay. So there we're at. On the right side, what can we pull out? Well, we know the left side remains y minus 1 squared, but the left side, if I pull out a -8, I am left with an x, and then 16 divided by -8 would be -2. So now what we have is a center, or rather a vertex, because this is a parabola. The vertex would be transformed to +2 and +1. So our vertex is 2, 1. Now, once I graph that, I go 2, 1 here. I recognize that this is going to be going downward or to the left side because of the fact that this is negative. But because y is being squared, this is going to go left and right here. And because this is negative, I'm going to push to the left side. So it's going to go here and here. So that right there is actually, although that's not a great graph, that would be sufficient for what we're looking for the conics unit. Now, the question becomes, what is the p-value? Because we remember that the foci is going to be inside and the directrix on the outside. And we've got to find both the focus as well as the directrix right there. Okay, so to find the p-value, we simply set 4p equal to -8. Notice that I only do this when I go from the equation to the graph. If I go opposite, I don't need to do that. I actually do the opposite by multiplying by 4. But we'll look at one like that in a second. So once I divide that by 4, I get p is equal to -2. And once I get p is equal to -2, I can recognize that this is going to go to the left 2, be right there, and this is also going to go to the right 2. So the directrix is on the outside. Remember, GAC is over here, okay? And because you're going away, because after graduation, you want to go away from it, this would be the focus. So the focus is at 0, 1 right here. And the directrix would be, since it crosses at 4, x equals 4, we would just put x equals 4 right there. And that would be the answer for what we're expecting for the vertex, focus, directrix, and the graph. That would be perfect there. Okay. All right, I want to keep going. Let's keep looking at ones that are just a little different. For instance, like number 6 that talks about the foci. This is an ellipse problem, but really good one in terms of just recognizing how to complete the square. So I want to do this one first and then kind of go forward on that and try to do some that aren't completing the square there. So this one is 25x squared. Now, since we notice both of them are squared and that it's an ellipse, we recognize that we've got to get it in standard form by putting the x's together. There we are, the x's together, as well as the y's together. So there's the y, there's the y. Perfect. Okay, so the 144 we could subtract to the other side, take it to the other side. Woo, woo. All right. Then we can approach this by saying, okay, is there something within the x's and y's that are in common that I can take out? Well, because of the 25 can go into both of these, we can take that out first to make 25 parentheses x squared minus 8x, and then we can close it. Same holds true for the 16y squared. When I pull out a 16, I am left with y squared plus 3y is what we get, and that equals negative 144. Now, one thing that I'm noticing, and actually I think I was off on that. I think this is 6. That's my fault. That's going to be much easier. So then what we're going to do is once I take that out, I'm going to take negative 8 and do the same thing. I'm going to half it and square it. Okay, so half it to get negative 4, square negative 4 to get positive 16. Okay, same thing with 6y. Half 6y, half 6 to get 3, square it to get positive 9. But we remember that 16 and 25 right here, this is really not 16 being added, and neither is this 9 being added there. Really, we have a 16 multiplied by 25 to be able to get us the value we're looking for. So really, 16 times 25, we're really adding 400 to this side because of what's on the outside here. So we're going to add 400 here. 9 and 16, again, just like we said, this is not really 9. It's really 9 times 16. So that would be 144 that's there. So we're going to take that out. So we're left with 400 equals all of this. And in order to get this equal to 1, which is standard form, I think this is the part that some of us forget a lot of times, is we divide this by 400 and then simplify and go from there. So 25 and 400, make sure it's to both of them. 25 goes into 400 16 times, okay? And 16 goes into 400. Make sure. 400 divided by 16. That is 25 times. So we're going to put that there. Oh, that makes sense because they just flip-flopped. Okay. So now once I complete the square and then I add it to the other side and now it's equal to 1 right over here, we then find the final equation by saying, what makes this the perfect square? Well, that would be x minus 4 squared over 16 plus y, perfect square here is y plus 3. Y plus 3 squared over 25, and there you are. So now let's write down a couple things that we know. First off, we know the center is at 4, negative 3. So we're going to put that down. And I would even put that over here. So we got 4, negative 3 right here. Because the 16 is underneath the x, we can take the square root of that and note that since it's underneath x, we get 4. And so it's going to go 4 to the left as well as 4 to the right. So we've got that there. And again, that's there. And again, remember, this is the b value because the a value is actually larger. It'd be the square root of 25, which is 5. And since it's underneath the y from the center, right, this is the center, we're going to go up 5 as well as 1, 2, 3, 4, 5. We're going to go down 5. And I can't quite get there. Let's see if we can. Yeah, there we are, right there. Okay. So once I graph this, I can graph this here by simply kind of starting low and then coming around. And we don't need to necessarily graph the foci here. We can if you want to, but sorry. But that's how we would have it. Kind of looks like a circle, but just off from a circle. So now, since we've got that, we can get our vertices here. And I know it only asks for the center, so, and I get that because we've already got that. But let's get the vertices too by saying that this is 1, 2, 3, 4, 2. And the second one would be 4, 1, 2, 3, 4, 5, 6, 7, 8. So negative 8. So 4, negative 8. So we've got our vertices. Last but not least, let's get the foci there. And we could get the foci by doing c squared equals a squared minus b squared. Get that on your formula sheet. A squared would be 5 squared, which is 25. B squared is 4 squared, which is 16. And as you can see, I get c squared equals 9. I square root it to where c is equal to 3. So really what I'm saying is if this is the major axis, and it is, from the center, I go up 3, boom, put 1 there, go down 3, boom, put 1 there, and those 2 are the points that we have there. So we really could take the center of 4, -3, and since we're changing on the y, we could say the foci points, foci is 4, -3 plus or minus, only on the y because it's going up and down, plus or minus 3. Which if you wanted to, since it was a whole number, you could just say that this is 4, 0 and 4, -6. And those 2 are the foci. So all of these things kind of incorporate together. As you do one, you kind of start getting the pattern of it, and then kind of go from there. You could do number 7 if you want to. Feel free to look at the answer sheet as you go through, because I know those are very important there. I think we did number 9 today in class with everybody. The hyperbola, yeah, this one's a little tougher. I'll come back to that one. All right, let's start with number 12, just because that's more of a basic one, and then we'll move in number 10 and 11, mainly just so we can kind of go through it there. But number 12, it tells us to name the slopes of the asymptotes of the hyperbola. But let's do all of it just so we've got it here. So we've got our center, you've got our foci, you've got our vertices. All right, there we are. So as I look at the center, I notice there's no transformation. So our 0, 0 value is what the center would be, okay? Now out loud, I want you just to scream at the top of your lungs, how would I find what A, B, and C are? It's exactly right. Nicely done. I hear you, Ryan. Nicely done. I hear a lot of you out there. Thank you so much for showing up there. But A would always be the first value, or the square root of that value, because it's always first within a hyperbola. And again, these will be given to you on the day of the test. So as I square root 4, I get 2 as my A. And to find B, I can just simply take the square root of 3 to get square root of 3. We'll just leave it as that. And really, this would be like 1.8, something along those lines, right? Something like that. So we've got our 2 values of A and B. So what we want to do here is, because the 2 is underneath X, which is the larger value, we're going to move 2 to the left and 2 to the right, okay? And B is 1.8 and 1.8. And since it's underneath Y, that's why we move it that way. So we've got our value right here. We got our ellipse. Our vertices would be the major axis points. So we would say that this is -2, 0, as well as 2, 0. The foci will move from left to right, and we remember the formula. It's c squared equals a squared plus b squared for a hyperbola. So if we take a and square it, we get 4. We take square root of 3 and square it, we get 3. So c squared equals 7, and we can actually square root that. So c is equal to, oh, I'm sorry, my fault. Back up. This is right up here. C is equal to square root of 7. What I messed up on, and I want to make sure I erase this over here, is this. Let's go here. Okay. So really, here's the center, right? But because it's a hyperbola, I graphed an ellipse. That's my fault. They look the same, but it was a minus sign, and so that's my fault. But we want to make sure we make our box here. Here's our asymptotes, okay? We do have our foci, so from the center, what we could do is, because of the fact that X is first here, we're going to graph this left this way and right, okay? So there you are. There we graph it left and right. And again, that's why our vertices is -2, 0, 2, 0. Not because it's the major axis, but because it's first. So that's my fault. I was thinking of an ellipse, but I was messing up there. But because this isn't a hyperbola, the points where they come in contact with, that's where we would have it there. But if Y was first, we would do the same thing, but now up and down. Now, as far as the foci goes, the foci from the center is going to travel to the left and to the right square root of 7. So instead of it changing on the y, this time it's changing on the x to where we would say 0 plus or minus square root of 7 comma 0. But because this is 0, you don't really have to say that. You could just say square root of 7 plus or minus square root of 7 comma 0. So it goes to the left as well as to the right, and there you go. Now, we haven't answered the actual question, which talks about asymptotes, but we remember that asymptotes is y is equal to k plus or minus rise over run times x minus h. And to do this, just simply plug in y and k, or h and k, which in this case is 0, 0, and we just say y is equal to plus or minus my rise over run times x. So my rise would be 2. Again, we're starting from the center of my hyperbola. We go up 2 to the right 2. It's actually, and it's really not up 2. It's really, as I look at it there, right, it's up 1.8 or square root of 3, and then runs 2, right? Runs 2. So we would say up square root of 3, and then it runs 2. So that's my rise over my run. When I look at my asymptotes, that's there. Hey, as you're looking at some questions, I know I'm going very quickly through this. I'm going to kind of slow down just for a second, enough just to ask to see if y'all have any questions. And so I'm going to kind of pull this up real quick and make sure that if there are any questions, we can kind of go through the chats on there. Yeah, so Scott, that's a good question. Why I went up 1.8 instead of 2, if you look at this here, okay, specifically the value here, if I took the square root of 4, that would get me a value of 2. So I would go 2 to the left and 2 to the right. However, and I should have gone down further. I think this is just a little off because when I went to 1.8. But when I take the square root of 3, I get, let's say square root of 3, and again, I could be off a little bit, whatever that decimal is. But I'm going to go up square root of 3 as well as down square roots of 3 from my center. So that's why I go up 1.8, not 2. 2 is what I go left and right with. 1.8 is what I go up and down with. I hope that makes sense to you. If it doesn't, please let me know on that. And I'll kind of hold on tight here and just kind of see if you have any other questions on that part, okay? All right, number 11, we'll kind of hit on to in a second. Again, make sure 13, really good one. I think I did this in most classes. But just a heads up, make sure -3, 2. If I say it's the center, kind of note that. Note if I give you like number, I think it was, like number 9. If I give you this information, know what you do with those 3 things. Look back at your homework. I know that those would be really good for you to be able to like go through it and that sort of thing. I might even rep one out just for the heck of it too, just to go through it together. But number 11 too, I will do this. Let me do this one. I'm gonna quickly do this one here, number 11. If you want to pause the video and then have yourself come back to it, just double check to make sure you know how to complete the square. But again, that's not the main thing, so I don't want to explain too much of this podcast away by doing that. But what I'll do is I'll do number 11 real quick, and I'm not going to put a lot of sound to it. Check it, and if you have major questions, come in. But the big thing I want to focus on is how I find the specs, the characteristics of that hyperbola here, okay? So I'm going to go center, vertices, foci, all right, and asymptote. Gotcha, I'm going to find all that. Before I do, I'm going to just kind of do this real quick, make sure we've got it. The big thing to remember is the negative squared value always goes second, so just a heads up there. All right, so here I go, and double check me. I want to do this. I think this will be good. So double check me when I'm done, but again, I'm not going to spend too long. I just want to make sure I do it, and then go from there. But as I am doing this, I will tell you that make sure that you understand how to graph these. This is the biggest thing is making sure that you know the logistics, you know the differences of each. If you can do that, I'm telling you, you could be successful on this test. I really believe it. So just a heads up there, just so you're aware of that. Just 225. So again, I'm just trying to go through this quick if you're joining us right now. And remember, we want to equal to 1. So this would be 9, 25. So what we've got here, so this is the equation, and this is really where I wanted to get at here. I tried to do it kind of as you float it out. Again, double check, make sure that I got it right, but then also make sure you got it right as well. To how you put it into standard form. Really, the big thing is what do I do from here? And I'm also going to go through one more like number 13 here in a second and just be sure that we understand completely what's going on. So let's say here on this part, we're trying to find all of these logistics. So when I do that, I would first graph this out. So we've got a minus sign, which tells me that if it's in the middle, and the fact that it says it's a hyperbola, that kind of gives it away to me to tell me that, all right, we're dealing with the hyperbola situation here. So when we look at the center, we look and see, okay, what can I transform these two to get me to that center? So I could go left 3 and up 1. So I'm going to go left 3, up 1. So my center is -3, comma 1. Good. Because of the square root here underneath the y, even though this value is 9, our a value, because it's the first value in the hyperbola, our a value would be 3, where our b value would be equal to 5. Now, this is important because we remember that 3, since it's underneath y, tells me that I'm going to go up 3 and down 3 from my center, okay? I believe so. Okay, someone just asked me if this is live. I believe it is. So if it's not right now, let me know. But I believe, because I think, Scott, you're on this right now. If you're not right now, if there's an issue with it, please let me know, because I want to make sure we take care of y'all. That's a big deal. I know that's a big deal there. But yeah, be cool. And give me the thumbs up. Can I like my video? Is that okay? I always, every time I tweet something, I like my video. Is that cheesy? A lot of times I only get like 1 like. So when I always think, like, when I like myself, like, people are like, people, like, that's 100% more likes than what I had if only 1 person liked it. So oh, got two likes. Can I like it like 3? Oh no. Okay, I didn't know if I could like it 6 times type of thing. But yeah, like the video, leave good comments, I think, or something like that. I don't know. So as we continue, this 5 goes underneath the x value. So because of that, we're going to go 1, 2, 3, 4, and 5 here. 1, 2, 3, 4, and 5 here. Remember, this is a hyperbola, though if I had a plus in the middle, it would also be my ellipse as well. It actually would look the same. There's no difference here. And then we got our asymptotes that cut across there. Okay. Again, since the y is the first part that's squared, we recognize the fact that these graphs will actually be, and this is really the red part is the actual graph, if that makes any sense. Like, the blue part helps us to get to the red part type of thing, like how wide is it and that sort of thing. So again, just a heads up there. So my vertices being here and here, we can say it's -3, -2 for my vertice, as well as -3, 4. So -3 and 4 is the second vertice. So now let's talk about the foci from my center upward and as well as downward. To find c, we're going to take a squared plus b squared equals c squared. So when I look at a squared, I take a squared and I get 9, okay? B squared being 25, so that equals 34, but I take the square root of that to get just the value of C. So really what I'm doing is I'm adding square root of 34 and I'm subtracting square root of 34 from my center. So I'll take my center because it's going up and down because y is the part that's first. I'm going to take the foci and say, okay, -3, that stays consistent, comma 1 plus or minus square root of 34. And there's our two foci. And it'll be somewhere in here and somewhere in here, but we see that those are the foci that we've got there. Lastly, we got our asymptote, which is y equals plus or minus rise over run times x. And really, I want to backtrack just a second because I kind of, does it just say the slope of it? Yeah, it kind of does, but just for the heck of it, remember the equation for the asymptote is k plus or minus rise over run times x minus h. So let's just plug things in, not just the slope. So -3 goes in for h, 1 goes in for k. So we'll say 1 plus or minus rise over run times x minus -3, so x plus 3 there. Now, what's the rise over run? Well, what we can do is from the center, we can recognize that we, to get to this spot over here, we rise 3 and run 1, 2, 3, 4, and 5. So rise 3, run 5. So I would say 3/5 x plus 3. So y equals 1 plus or minus 3/5 x minus 3. Cool, cool. Ooh, we've got 4 likes going on. Look at this. This is a record. Right now, I've got 2 views right now. This is good. And no dislikes. Look at this. Can I dislike and like my video? I don't even know. I'm going to be like Dora the Explorer. Yes, I missed my calling, y'all. I did. I missed my calling. Maybe next year. All right. Okay, last but not least here, we've got I'm going to give you a couple things. This is unrelated to 13. This is just another rep, okay? Let's say that this is a hyperbola. Hyperbola right there. The center is at 2, 1. Let's say my focus is at, I don't know. Let's say it's 4, 1, okay? Let's make that, I'm sorry. Let's make it 6, 1. Make it a little bigger. And let's say the vertex, there's 1 vertex. Now there's 2 normally, right? I'm only giving you 1. Let's see if we can solve for it. So the vertex would be at, let's say 4, 1. So what we've got here is we've got 2, 1. It's my center here. 4, 1 is my vertice. So I've got my center, vertice, and focus would be at here. So focus would be at this spot. So because of this, the center is from the center, vertices going left and right, 2. So I'm going to put those 2 orange dots in as vertices. So 0, 1 is my first vertice, and second vertice is 4, 1. But they really want me to put this in standard form. And so we recognize that since it's going left and right, this graph is going to go here and here, and it might not be exact, but the parabola or hyperbolas on here will go left and right in that direction. And because it's left to right, x is going to be first. So we're going to have x minus h squared over a squared minus y minus k squared over b squared equals 1. Now, since the distance from the center to the vertice is 2, we simply plug 2 in for a to get a total value of 4. And since the center is at 1, 2, okay, kind of make sure I put that down there, 1, 2, or I'm sorry, 2, 1, my fault, 2, 1. What we can do then is at 2, 1, we could plug 2 in for h, x minus 2 squared, and 1 in for k. Okay. Now, getting b is a little tricky, but we remember that c squared equals a squared plus b squared, where a squared would be 4, and b squared we're not really sure of. But we know c squared is from the center to my focus. That's a distance of 4. So 4 squared is 16. So once I subtract 4 and subtract 4, I get 12 is equal to b squared, which just so happens to be the same exact value that I'm looking for. So I could just plug 12 in for b squared, and there we go. Voila, the equation of a hyperbola. But that's just an example of something where if I gave you specific points and I tell you what's a hyperbola, parabola, ellipse, we know how to attack that, just like number 9 would. Okay. Okay, yes, good question. So the difference between the center and the vertex, it depends upon the problem. So for instance, if I went to a parabola, I'll just kind of go over here, and Pauline, you may know this already, and if so, I'm sorry for going over it again, but just in case this is your question, let's pretend here that the vertex is at 0, 0, and the focus is at -4, 0. So here's the focus, right? We remember that because the focus has to be inside, that this graph would actually go left and right. You probably know that. But because of this, this does not have a center, but simply a vertice, or vertex in this case, okay, because it's singular. But if I went to an ellipse, the center is the middle data, middle value. That's what I get from setting the top equal to 0 as far as the transformations go. So +4, -3. That's the center. The vertices, this is good here to know. Vertices for ellipses is the endpoints of the major axis. Okay, so that would be like here and down yonder here. Okay, all right, so those are the 2 vertices because they're the major axis points. But when we come to hyperbola, a little bit different. The center, it's like what the center of the box is, very similar to the ellipse. If I were to draw an ellipse, it would look something like this, right? Okay, you'll notice that again, basically the same thing, same process at the beginning. The only difference is with the hyperbola, whatever's first is what it's graphed here, right? So because the y was first, the y minus 1 was first, we graphed it up and we graphed it down. The vertice points are these 2 points, both here and here, where it touches the box. The center is like what is in the center of the box that's there. It kind of helps me create the box. To find the center, that's what, just like an ellipse, that's what you set both of them equal to 0 to solve for both the x and y. Great question. Does anyone else have any other questions there that you have specifically? Are there any ones that y'all are like dying to kind of know or dying to go over? I'll kind of hold off for just a second, and then I do have one more that I'll wrap up on, but I'll kind of wait for about 30 seconds before we begin, and then we'll get after it there. Have some fun and rock and roll on this test. Tomorrow morning I will be there. If you want to show up at around 7:15, the earlier the better for you, and should be good. Kind of go to one last question here. Let's see if I can. I kind of talk through real quick. Remember here, like the center being 0 and 2. So just make sure of that. A is the major axis, right, for an ellipse. So that would be 5. So this would go 5 up and down on the major axis points, which is our vertices. And then we'd go square root of 10 left and right, which is like 3.1 or something. Just a heads up there. See here, went through that one. Kind of already went through this one on number 2. Just a heads up, make sure. So this distance here from foci to the vertex is a distance of 4. So P is 4, right? Which tells me that 1, 2, 3, 4, the directrix has to be here too. So the directrix would be at x equals 4. The focus would be at -4, 0, right? And it's already listed. The equation, because it's going left and right, would be y minus k squared equals 4p times x minus h. Since h and k are 0, 0 because the center is at 0, 0, we can leave those out to say y squared equals 4p times x. Well, since it goes to the left side, that means it's going to be negative. And since p is equal to 4, we simply plug it in to get y squared equals 4 times 4, which is the p value, negative 16x. Because, again, it's going left, and that's how we figure out that it's negative. Be careful, too. If I give you the vertex and directrix, remember center is in between, okay? So center's in between there, all right? Okay, vertices here. I don't think, did I already do that? This is a good one, too, for an ellipse. If I say vertices are at 4, 1 and 4, 9. Oh, hold up. Is this a, no, I'm sorry. This is a, hold up. Wow, that was great. Okay, I think this is hyperbola. My fault. Again, I'll say here, but if you notice, you'll see why. 4, 9 would be here. The foci is at 4, 10 and 4, 0. You'll know they're on the outside. So remember, the ellipse, the foci are on the inside. So it goes here and here. We recognize that the center would be in between. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. So the center's in here. So that would be like 4, 5, right? That'd be the center. The C value would be the distance from here to here, and then in between. So C would be 5. A would be, because the y is going up and down here, and we're graphing it, y would be first in this equation. Y minus k squared over a squared minus x minus h squared over b squared equals c squared. Oh, I'm sorry, equals 1. Wow. Equals 1. Where h would be the 4 value, k would be the 5 value. So we would have y minus 5. Let me put it up here. Y minus 5 squared over the distance from here to the vertex. Remember, that's a, right? That'd be 4. So 4 squared is 16 minus x minus 4 squared over v squared equals 1. And remember, since we know that a is 4, c is 5, we can just use our equation of c squared equals a squared plus b squared, where a squared would be 16, c squared would be 25, subtract 16, subtract 16, 9 would equal b squared, and 3 would equal b. So once I plug this in, 3 squared would be 9, and there you are. I know it's a lot. Hopefully that makes sense. I know that was kind of a bonus one, but if you wanted to, you feel free, ask some questions there, and then rock and roll. Okay, so going back to that one, make it sure. Why do I not? I'm going to make sure I've got this right. I think this is the one we did, right? So we did this one, and we got, is it this one that we did? Okay, Pauline, maybe this will help. So do you see how on this one we're going from the equation to the graph to our characteristics, right? Where I don't know these, but I'm going from here to here. So once I got to -8 down below, to find my p-value, I set 4p equal to that -8 value. To get that p is equal to -2, I go left 2 and right 2. Now on this one, just a little different on this one. I've given you the vertex and focus. You've got to give me the equation. So when we remember 0, 0 here, -4, 0, and we remember that it opens to the left, and with the equation, we got that it was y squared equals -16 x squared. The reason why we got -16 is the standard form of this is 4p times x. I'm not setting 4p equal to 4. Why? Because the p-value is 4. The p-value isn't 1. The p-value is the distance from the focus to the vertex. So since that distance is 4, this is going backwards from what we did earlier. Remember, we're going from the equation to our characteristics. So once I get it in standard form, I set it equal to 4p to solve for p, to then help me find the distance from the vertex to the focus and the vertex to the directrix. Whereas this one is doing the complete opposite. So I'm not going to set 4p equal to 4. This time, since p equals 4, I plug 4 in for p, and I get 16x, and because it's going to the left, I would then make it negative. Okay. Hey, I hope that helped y'all. I hope that helps out. Again, I'll kind of hold off for just a couple more seconds. If you do have any other questions, feel free. There's another video down below. And then also feel free, if you want to come in for help there. And we'll look at some of those together. The only other thing I would tell you that would be appropriate is if you start getting kind of bogged down with completing the square, again, it is appropriate if you want to go online on the online forum there, on the review answer sheet, and get the equation and then find the center and all that. I'm actually okay with that this time. Mainly because that's not the biggest thing. But I did want you to get some practice. Some people need more practice than others. But the majority of the problems won't be like this. It will be more characteristics. There'll be a lot where you work backwards, like number 9. So just be leery of that as you go through. Okay. All righty. Well, I'm about ready to embed this and put this online for us. Again, if you have any other questions, let me know. But sayonara, y'all. Love y'all. Keep studying. Keep working hard. You are almost done. See y'all. Bye.